Alright, so today we're starting with 1.6. Today is day 3 of grade repair. So this is the last video that you'll be watching before you take your test. And so today we're talking about graphing using tables, and it tells you right here to graph the function by creating a table of values, and then here's your function. So you are going to need some kind of straight edge or ruler. An ID card works as well, so I have my ruler here. And you are going to need your phone app or a calculator. All right, so the first thing I'm going to do is I'm going to go to where it says y equals and press it. If I have anything there, I'm going to clear it, and I'm going to type in 2x minus 1. Remember, the x is this button right here, and then minus 1. If I press graph, I can see what the graph looks like. And when I make my table, I want values on the left and on the right side, meaning I want values to the left of the 0 or the left, and then I want numbers to the right of the 0, so this side over here. So that's what I want to keep in mind when I'm picking my numbers. Then to access the table, we're going to go to second graph. So second graph, and now I have my table. Like I said, I want to accommodate both the left and the right side. So I'm going to start off with -2. And I'm going to go up by ones. That way I have a little bit of the negative side, the left, I have 0, and then I have the positive side. Then the numbers that go with these x's for the y, right, because this is x, this is y, I'm going to write here. So the -2 goes with -5. So that's what I write here. The -1 goes with -3. The 0 goes with -1. The 1 goes with 1. And the 2 goes with 3. Okay, I don't need my calculator anymore. I'm going to put it to the side. The last thing I have to do is I have to write it as an ordered pair, as a point. So this is written as -2, -5. This one is written as -1, -3. Okay, I have 0, -1, 1, 1, and 2, 3. Okay, perfect. The last thing I'm going to do is I'm going to graph, or I'm going to plot these 5 points on my graph over here. So I have -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. Then you're going to take your ruler or your straight edge, your ID card, and connect them to make a straight line. Remember, no baby graphs, so you want to make sure that your line goes all the way through the top and all the way through the bottom, and don't forget your arrows. So that's how you can use your calculator to create a table of values, like this one, and then you use those values to make your line. All right, in the next example that we're going to do, we just have to fill out the table. So I'm going to plug this new function into my calculator. So to get out of this screen, I'm going to go back to the y equals. I'm going to clear that. And now I'm going to type this in, -4x minus 2. Okay, remember the x is this button right here. Then to get to the table, I'm going to press second graph. Second graph. These are the x values that they give me. I'm going to match those and find them and then write the correct y number. So remember, this is x and this is y. All right, when x is -2, I was already on there, y is 6. When x is 0, y is -2. When x is 2, y is -10. And when x is 3, y is -14. The last thing you have to do is, I can put my calculator to the side, is write this as an ordered pair. So putting them together like this. So this is -2, 6, 0, -2, 2, -10, and 3, -14. Perfect. So you just use your calculator to help you find the y values and then write those as ordered pairs on the side. All right, great. We're going to move on to 1.7. So we're going to talk about key features of graphs. So one thing you want to notice is that whenever you're given some type of graph like this, sometimes the arrows don't print right. So we are going to add our arrows. And now we can answer some key characteristics. So remember, your domain is from your x's, so from left to right. So this is my x's. This is from left to right. My line is going to the left forever, and it's going to the right forever. So my domain is all real numbers. Remember, all real numbers can be written out like this. You could also draw the symbol. To draw the symbol, you could draw the number 11, and then you make an R with the both of them. Okay, we can try it again. Your range is the y's. Remember, that's your up, down. This goes up forever. This goes down forever. So your range is all real numbers. You write the number 11, and then you connect them and you make an R. X-intercept is, where does it touch the x-axis? It touches right here. At that point, make sure you don't just write 4. We got to write 4, 0. That's my x-intercept. Okay, now I'm going to do my y-intercept. Y-intercept is where it touches the y-axis. It touches right here. This is at 0, -2. That's my y-intercept. Your minimum is your lowest point. Do you physically see the lowest point here on your line? You might say, oh yeah, it's right here. But be careful, because this goes down forever. It just keeps getting lower and lower and lower and lower. So is there a minimum? No. So we're going to write none. Okay, we're going to do the same thing for the right side. Is there a maximum? Well, you could argue and say, well, I see it's right here. But be careful, because the arrow, this keeps getting higher and higher and higher. So you don't actually have a maximum. So we're going to write none. Let's try example 2. All right, same thing. We're going to add our arrows. My domain is my x's. So my x's. From left to right. My parabola, my graph goes to the left forever, and it goes to the right forever. So this is all real numbers. My range is my y's, so up, down. So here you have to be careful. I go up forever, but I don't go down forever. You see how I can see the lowest point on my graph? I physically see this low point right here. Okay, I want to write the coordinates for that. That's at 3, -4. This is my x and this is my y. Remember, range is y's, so I want this number, this -4. Your range is associated with the letter y. And because your graph is pointing up, this is greater than or equal to. Okay, I'm going to see if I have any x-intercepts. That's where it touches the x-axis. It touches here and here. This is at 1, 0, and this is at 5, 0. You have to write the full thing. You cannot just write 1 and 5. So my first one is at 1, 0, and my second one is at 5, 0. Y-intercepts is where it touches the y-axis. It touches the y right here. That's at the point 0, 5. So I'm going to write 0, 5. All right, minimum. Minimum means my lowest point. Do you have a lowest point on your graph? Like, can you physically see it? And we said at the beginning we did. Yeah, this is my lowest point. So whatever point that is, that's my minimum. So this is at the point 3, -4. My maximum is my highest point. You might argue that it's this one up here, but you see how I have my arrows? It goes up forever. So because it goes up forever, I do not have a maximum. So I write none. All right, last one. Evaluate f of 3. This is telling me when x equals 3, what does y equal? So when x equals 3, my y equals negative 4. So when x equals 3, not the comma, sorry. When x equals 3, that equals negative 4. That's the same as my minimum. And what's so special about this point? Well, this point is the minimum. That's why it's special. So there are two parts here. Part 1 is to evaluate it, which is this part. And part 2 is the fact that it's the minimum. That's what's so special about it. So just be careful, there are two parts there. All right, we're going to the page to 1.8. All right, for this one, we're going to be analyzing graphs and situations. So we have Romeo, who decided to monitor his distance away from his house throughout the day. His distance away from home can be modeled by the function d of x, where d measures the distance in miles he is away from his house, and x represents the time of day. The graph of d of x is shown below. Use the graph to answer the following questions. All right, so this is the time of day starting at noon. So that means this is 12 p.m., this is 1 p.m., 2 p.m., and so forth, right? And then on the left is the distance from house in miles. So at 0, this is where his house is. So the further away up he is, the further away he is from his house. Okay, the next thing we should do before we start answering or looking at the questions is looking at the distance between each time of day. So between 12 and 1 p.m., it went from 0 to the middle of 2 and 4. We can go in and plug in these numbers. So in between 2 and 4 is 3. There should be a 1 here, 5, 7, and 9. Just to make it easier for us later on. All right, to go from 0 to 3, that's an increase of 3. To go from 3 to 4, that's an increase of 1. To go from 4 to 3, we went down 1. And I'm looking at these numbers on the side. To go from 3 to 7, that's an increase of 4. To go from 7 to 9, that's an increase of 2. To go from 9 to 8, decreasing 1. From 8 to 5, decreasing 3. And from 5 to 0, it's minus 5. I think that'll help us later on when we are answering some of the questions. Okay, so let's look at part 8. A says, how far is he from his house at 4 p.m.? Well, I'm going to look at 4 p.m. I'm going to go straight up. I want to see how far away he was. He was 7 miles away from his house. So, full sentences here. At 4 p.m., Romeo was 7 miles away. B, what is the maximum distance Romeo was away from his house? So look for the maximum, look for the highest point. My highest point is right here. That was 9 miles. So the maximum distance Romeo was away from his house was 9 miles. And we want full sentences, right? On the test, you will be expected to write full sentences. All right, letter C. What is the meaning of D of 2 equals 4? So 2 is my in, 4 is my out. You could also say this is my X and this is my Y. Sorry, it's really small. My X-axis is the time of the day. So the 2 represents the time of day. So at 2 p.m. So that's the first part. The 4 represents my out or my Y. My Y is the distance from house. So at 2 p.m., he is 4 miles away from his house. So at 2 p.m., Romeo was 4 miles away from his house. Okay, perfect. So what I want to do is the next 3 are try-its. I would like you to try them on your own. So you can pause the video here and answer questions A, B, and C in complete sentences. So pause it here. Once you finish, come back and I'll show you the answers. So I am going to switch my paper to show you the answers so you can pause it. All right, hopefully you tried those on your own. These are the answers you should have gotten. So at 7 p.m., Romeo was 5 miles away. At 8 p.m., Romeo was home. And then between 6 and 7, Romeo was walking towards his house. So he was going down so that he was walking towards his home. If you got all of those, awesome. If you maybe missed 1 or 2, that's okay. Hopefully you can understand why. And we are going to turn to the last page, 1.9. All right, today we're going to talk about function notation. Function notation means f of x, but we already knew that because we've been talking about it. So for example 1, we want to find the next 2 terms in our patterns. For all these examples, we are adding or subtracting, okay, to make it a little bit easier on us. For letter A, to go from 5 to 8, I'm increasing, and I'm increasing by 3. To go from 8 to 11, I want to check to make sure I'm doing the same number. I'm still increasing by 3. From 11 to 14, it's still by 3. And 14 to 17, it's still by 3. So always double check because you never know. Then I have to find the next 2 terms. So then if I continue my pattern, 17 plus 3 is 20. And then if I continue that pattern, 20 plus 3 is 23. So those are the next 2 terms. Okay, let's look at letter B. I'm increasing, so to go from 1 to 3, I'm increasing by 2. And I want to check to make sure that works every single time. So then here I'm increasing also by 2. 5 to 7 is still by 2. 7 to 9 is still by 2. Okay, good so far. If I continue that pattern, this now becomes 9 plus 2 is 11. And then if I continue that pattern, 11 plus 2 is 13. All right, I want you to try letters C and D. So you can pause the video here, and then once you finish those, come back so that I can show you the answers. Okay, so I'm going to switch my paper. So for letter C, it's decreasing by 5. And so you get 74 and 69. And letter D is a special case because you'll notice that it changes between each number. So you're adding 1, then you're adding 2, then 3, then 4, and so forth. So if you follow that pattern, you should have ended up with 24 and 31. So hopefully you did try those and you got those answers. Okay, perfect. Let's talk about the last 4. So writing the rule in function notation means f of x. So when you're doing these, you want to write a pattern or a rule, meaning you want to write an equation. So all of your equations should look something like this. The two numbers you're trying to find are your m and your b. Okay, remember b is your start, and m is your slope or your change. All right, so if I'm looking at this pattern right here, the first number that pops up, this is my start. So that means that my start here is 3. So my b equals 3. Sorry, let me mute that. Okay, so then I want to find my m or my change. So what am I doing each time to get the next term? I'm increasing by 3, so I'm adding by 3. Make sure that works every single time. So 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. So that works. So this number that I'm changing by is my m. So these 3's represent different things, okay? Just FYI. Then when I'm writing my equation, I'm only replacing these two. Sorry. So then when I'm writing my equation, I'm only replacing the m and the b. So I get f of x equals m is 3, b is also 3. That's my equation. Okay, let's try letter b. So identify your start. The first thing in my sequence is my start. That's my b, so b is 2. And then figure out what your change is. So to go from 2 to 6, I'm increasing, and I'm increasing by 4. And then I want to check 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18. So everything checks out. So then my change, my m, is 4 or plus 4. Those are the two that I'm going to replace in those spots. So f of x equals 4x plus 2. Okay, let's try C and D. All right, this 4 is my start. So B is 4. And then I am decreasing. And I'm decreasing by 3. If I do 1 minus 3, I get negative 2. Negative 2 minus 3, negative 5. Negative 5 minus 3, negative 8. So that works out. My change is negative 3. So then when I write my equation, I get f of x equals negative 3x plus 4. All right, last one, D. So I'm going to identify this is my start. So B is 1. My change is decreasing. I'm decreasing by 6. If I check that with every single thing, it's the same. So my m equals negative 6. If I plug those numbers into my equation, I get negative 6x plus 1. Okay, we have officially finished the packet. You are going to turn this back in, and then you are able to retake your test. If you have any questions, please talk to the appropriate teacher that you are reporting to. And yeah, best of luck on your test.